Hello friends, let me show you the best way of mastering software development. I will not talk for junior developers. Yeah, there's a lot of courses, a lot of stuff on YouTube for junior developers. I'm talking about something more hardcore, something more proficient, something that is hard to obtain. So let me onboard you on what we are doing on this channel. Hold on a second. So modern times are awesome. We can grow faster and stronger than ever because we can train non-trivial skills. So on this channel, we are not doing lead code because lead code is bullshit. It's simple. It's not real life software problems. But we have a lot of real life software problems and solutions in public domain, like open source. For example, Node.js. Yeah. For example, Linux kernel. Yeah. For example, Linux kernel was written by very professional developers like Linus Torvalds, yeah, and you can read their code. You can actually read their code and see their thinking process. You can actually go to Node.js source code repository and check issues and pull requests on this repository and see how the top developers interact, see how they write code, see what solutions they propose, see what the problems they are. So you can learn like a lot of stuff from this, like extremely a lot. So I'm proposing for you a practice that you can do with me or on your own. Yeah, we are opening some open source project from big one, for example, Node.js. We're picking like solved pull request, solved issue, yeah, by this guy, for example. We are doing today this guy. And we are trying to understand this issue. The key moment is here that's like I am not good with C++. I was writing professional C++ 10 years ago. I don't know like good internals of Node.js. This is like extremely hard for me. And because there is such a big gap between my current skills and skills of their guys, I can learn like a lot from them. So real life problems, hardcore skills. So if you combine these two components, you can achieve like extremely high levels of mastery. So let me onboard you on this issue, what we are going to do today. This issue is quite interesting, yeah, because it touches multiple language layers. It touches JavaScript, it touches C++ and C layer. So in C layer, we have like SQLite library, and JavaScript wants to call this library with apply change function. And this function is missing this lambda. And the whole issue is described is like we want to add support this lambda to this function. Pretty straightforward, but to do this issue, I need like to grow like a lot, because when I installed the Node.js and tried to compile, the compilation was successful, but my environment was like completely red. And we solved this like with bear. Like modern way of making C++ resolve C++ dependencies is using bear, and we learned this craft. It's quite interesting. Then we learned how to put breakpoints in our code base and how to debug with LLDB. It was also very cool. So we now can put breakpoints inside our C++ layer and code Node.js in JavaScript layer and actually hit our breakpoints and explore this environment. But today we're going to do something special. We're trying to understand V8 because we get to the layer of the V8, and this is extremely challenging topic. Let me onboard you on this. So the main idea of Node.js, what is Node.js? It's a C++ project that takes V8 JavaScript engine and takes asynchronous input-output, asynchron I/O, and some standard library, and combines these together in one huge blob. The name is Node.js. So Node.js can take input from web, process it with V8 JavaScript engine, and produce output. Pretty straightforward. So most of the code of, of Node.js will be a glue between JavaScript V8 and between C++ or C libraries. So let me show you. So before we start, let me start our timer. I don't have much time to. I have like 1 hour each day because I have daytime job, and I give myself 45 minutes to practice daily. It's a good time. It's a good intensive workout. So let's start our timer and begin to understand Node.js and trying to solve this issue. So I apply change send function. Let me onboard you quickly. So we have like unit test in JavaScript. Yeah, this JavaScript calls apply change set function, and it calls some lambdas. Yeah, and we're trying to understand how this guy added this lambda. Yeah, how to add the support of this lambda to this function. So what we have discovered is we can call our C++ code And here, everything here, is just glue between C++ and between JavaScript. And the only business logic we have here is this one. Yeah. So this is like SQL library, and it is code. Everything above is just a glue. Today we'll try to understand how this glue actually works. So everything you see here is a part of V8 library. What is V8? Google made a JavaScript engine, and now it ships this engine with everything, like with their browser, Google Chrome, or, for example, we can use Node.js to add JavaScript functionality to our project. And for example, and what is the base idea of how V8 works? It has concept of isolates. What is isolate? Isolate is a virtual machine of JavaScript. It's like workhorse with memory where you run your code. It's isolate. It's named isolate. So you can have like several isolates on in your memory, but we'll usually use one here. And you can create context in isolates. What is context? Context is a global JavaScript state. So you can have one machine and have several isolated contexts on this machine, and they will not interfere with each other. For example, you can have several iframes in your web browser page, and each iframe will have its own context and can't access data that was added in different iframe. So it's pretty secure. So there is like isolates, context, and there is also one thing is scope. Do we use scope here? Local scope. Yeah. Where is scope definition? Yeah, we don't have scopes here. So what scope is? We can have in JavaScript references. Yeah, this local is a reference. Local reference to something, to object, or to like random value, or to function. If you know JavaScript, you know what this reference is. So reference should live somewhere, and they usually live in a scope. So when scope is created, you can attach to the scope references, and the scope destroys, all the references will destroy, and garbage collector will collect memory of these references eventually. So usually you need to create scope and attach there some local references, but here I think scope comes from upper level, so it's not very important scope for this one. So let's study V8. I actually read some V8 documentation getting started with embedding V8, and this was very useful. What wasn't useful to try to understand V8 via YouTube videos. There is no much good content about V8 on YouTube, on how it works in details. Yeah, but we can get much more from documentation. So let's try to understand this code. Yeah, I'm really interested in how V8 works and how can we implement this. So it's just JavaScript function. You get some arguments. You can add this argument for, excuse me. So this function goes from JavaScript, and it has some arguments, and from arguments you can get this. If you write with JavaScript, you know what this is. This is complex. And basically this guy does just casting this, what is this? What type is this? Local object. Some random object is cast to database pointer. So this cast is really interesting. I want to show you guys why people hate C++. They hate it because of their type system. I believe so. I haven't written in C++ for 10 years, but let me show you what I mean. So, and for the macros, yeah. So instantly, this is a macro, yeah. This will be replaced. So this line will be replaced with this line during compile time. So some casts, yeah, we cast something to something. This code does basically nothing except to make type system work correctly. So it's for compilation, not for like actual execution. And we call some base object, okay, from JSON object. So what this code does is try to resolve value to some JSON, yeah. It takes some like value pointer. Value is the most simple type in JavaScript. It's just like any other type. So you have value from our grows objects, numbers, strings, and everything else. So it's like base type. And they want to just cast this value to their true form. And the true form is JSON objects. So, okay, how this cast actually works? Again, this code does nothing, only converts types. So what about this one? This one does some checks, but basically also just casts types. Let's go further. What this code does some checks during runtime, so the cast is valid. But basically, it's called another layer. What this does, and as you can see, I can't jump anywhere else. Why I can't jump further? This is interesting. Let me show you where we can jump further. So I don't know where we can jump further, but we go further. So what does this does? Again, some checks. Again, some casts. And well, it just goes another cast. And this cast we can find, and this cast we can't actually find. Interesting. So this is like the last cast. And in C++, you can quickly understand that you can't jump to the definitions because they're sometimes made with macros, and my environment can't find these definitions. Holy moly! So basically, all this is calling like a lot of casts, and in the end, the only thing it does is converts from local object to DB. And this pretty much that's pretty much it. So like this is why people don't like C++ because like type system is enormously complex. All these casts are insane. Usually I prefer to avoid them. So for example, in TypeScript, I would like to use like as database sync, and just doesn't check anything. And maybe it's a bit of more dangerous, but it's like just type system. You can dynamically fast test this function to validate its correct use. So dynamic tests are more important, much more important than static type checks. But let's continue. So again, like what's this? This is another layer that calls another layer and another layer and another layer. But basically, we can get environment. This is how we get environment from arguments. This is how can we resolve this to something, and this is how we can get environment from arguments. Okay, what is environment? Environment is it's cool question. What is environment? Environment is some global state, I believe. Environment is a pre-isolated data structure that represents execution environment. Each environment has a principal realm, and environment can create multiple subsidiary synthetic realms. Some global state, I don't know. Then args have this pointer. Args have an environment, and args has also arguments. Yeah, the first argument should be array. Okay, this is like change set. Second argument should be defined. Okay, this is I can understand everything of this. So again, some cast, like we take object. We cast first element as an object. So for example, how these casts work? This cast costs different cast. And again, I can't find definition because my definitions are broken right now. Very interesting. Anyway, this is some cast. This is how we can extract from arguments some objects. It's okay. It's not very important. What's the next? Conflict value. So options is object. Yeah, this is JavaScript object, typical reference to a JavaScript object. And it's attached to some context that we don't see. And we can also extract some variables from it. And this is context. Context is like global state. So main idea, you need context to do anything. But what's context? I thought that context like isolated parts. Yeah, I think it's like isolated execution environment with some global state. Yeah. So to extract something from context or from options, you need to say in which context we want to extract, because we are creating new references and resolving them. Okay, this is just basically const string. So this is some macro magic, but this is like just produce const string. And this one is fun. So in C++, can I see B? Yeah, in C++, each function can have only one return type. So it's not like JavaScript or it's not like TypeScript where we can return different types. It's not like JavaScript where we can return different types. Yeah, you can return only one type. But what if you want to return value or null? So you need to create some wrapper around this type. So this wrapper tells us that it can have the value or null. And to resolve the null, they do this call. And basically, this gives us just local value. Yeah. Without it, it's just without it, it will be maybe local, which is not useful. Blah blah blah. Some assertions. Argument is a function. Creating lambda. Yeah. This is I can understand everything of this. So, what I don't understand is there a part that I don't understand. This one, this maybe was before there. So pretty much it, I believe. I believe I can understand everything. So we are ready to solve our problem. So to solve it, in current state, the problem was actually solved. Yeah, it's not useful for us because the problem is actually solved. What we need to do is to reverse these changes and try to write themselves. Can we reverse them? So this is our pull request. This is 12 commits. This is the first commit. We can find this first commit in our Git history, like here. Here's this one. And the one commit before it, like here, we can take it and check out our code base to this guy. Yeah. But before we can check out, we need to revert changes. Yeah, we need to revert them because it will be blocked. And get checkout this one. Okay, now we should have, yes, now we should have our apply changes and functions is what hasn't been fixed. This is like it's raw state. Yeah, this is our callback, and callback doesn't support the lambda. So finally, after 5 hours, we can actually start typing our solution. I'm a bit scared. So we have our test file, and we need to provide some tests for it. We need to provide some tests. So what we can do, should what? Should support lambda function in apply change set. Let's do this. So to do this, we need to create memory or create database, of course. And we will start from test. We will try to write the test today, and then we can, using this test, we can run it with only mod, and we can attach some breakpoints here and see what we can do. But before we can actually solve it, we need to formulate our problem. To formulate it, we need to write the JavaScript test. So it's cool to start with tests every time, most every time. So how to do it? Change set, throws, exec, session. So we need to create a table in our database, of course. We need to add some variable to table. Why not? And then we will create a different database. Yeah? A session. No, I want to have a different database. Do we have an example of 2 databases? Why I have like red line here? It's gone. Okay, whatever. Do we have example with 2 databases? So we can grab a solution. No. Oh, yeah, we have example with 2 databases. How we're doing it? Let's completely grab it. Let's completely grab it and put it here. So we have our example of 2 databases. We create table. What table do we create? We have 2 tables. I just need one table, and I need to write there some data, and then I want to produce change set from these operations and apply to the second database. And on second database, the thing should crash and produce on conflict. and produce on conflict call, so we can cache it. It's pretty straightforward. So we can create 2 tables. We don't need 2 tables. We need 1 table. Let's remove this one. We don't need it. We insert 1. Why not exec? What is exec? I don't need exec right now. I need change set. And apply change set. I don't need filter. We will not use filter today. And prepare strict equals. I don't need this one. I need some change set example. Do we have here it? Prepare how to create change set. So how to make a change set? Sessions change set. So to produce, why it's red? Let's restart. So to produce change set, we need to use session. So we need to create session. Okay. Like no problem. I don't see problems here. Let's create session. I will have session here. Let's create session. Let's create table. But we will create table not instantly. Yeah. So what we will do, we will like create database, create table, and then we create session. So this change set will not contain this call. So change set is just like an array of all operations that you run. So you create session and you can collect your operations and produce change set, and this is like a full packet of operations. So you can send this packet to different database, and it will execute. So sometimes it's useful. I believe I never use it, but whatever. So we have database 2, and let's insert here. So we have database 2, and yeah, like here. So we created our database. After we created it, we can start to create our change set. Our change set will contain like this value, but we did not contain creating of table. And then we create second database, and we try to apply a change set from the first one. We will get an exception because there is no table, and we try to insert it. So basically, that's it. It should call an exception and produce on conflict. But this on conflict is not lambda though yet. It's null throws. Yeah, I need to know how they write unit tests here. So yeah, currently on conflict is some constant, but we don't want constant. We want to have a lambda, and this lambda should return what? Oh, hold on a second. No, why can't return? Yeah, so this lambda should return a meet, change center meet, maybe. So what this lambda does? So when you have something conflict with change set, this lambda is called, and then it asks us what needs to be done, and we tell this lambda to just like ignore everything. This is the ignore operation. Emit replace abort. So emit will just ignore the operation, and abort will throw an exception. So let's just emit all errors. Yeah, why not? And hold on a second. I think I changed in the wrong place. It's yeah. I need this one. Yeah, like this. So wait, don't format. I believe my code is not formatting correctly, and I don't know why. Let's check. We only added this one. It's very strange. And this one works. So if I like delete everything like this and do like this and make like this, it doesn't format. Huh. I believe I format with prettier, and they don't have prettier in this object, in this project. Prettier, yeah, pretty. Yeah, there's no prettier in this project. We need to install prettier, guys. for formatting. But this is not very yeah, I will instance it later. So nevertheless, what will happen is just I run this test. What will happen? How to run this test? Pretty straightforward. You need to call. I need to exclamation mark. Everything passed, never failed. Interesting that it's not failed, and we edit lambda. Can we have our breakpoint actually triggers? Can we trigger our breakpoint? Can we tap new node? And we can't trigger our breakpoint. But why though? Here breakpoint, and we run. There is something. We switch to different version of our code, yeah, and we need to recompile C++ to basically, yeah, because we like switch to different version of our branch. We need to recompile it, so we need make, we need configure Ninja, I believe, debug. Yeah, let's use Ninja build system. Yeah, and let's run make jobs 9 on 9 cores. So as you can see, Ninja will recompile like a lot of stuff. This is unfortunate, but we need to wait. How much time do we have? We have 16 minutes, 16 more minutes. So let's continue with this. Let's learn how we can assert exceptions on and errors in JavaScript part. So we want to check this test is not crashing at first, and it will not. What we can else test? We can test that the second database has no records and the first database has records. For example, how to do it? How to request records from database? Let's search here. Insert, create, blah blah blah. Select. Select would be nice. Yeah. Prepare select. Okay, let's check selects. So this is how they do select. What is the result? Change set. Apply changes returns something. Result true or false. It returns true, I believe, if it can apply change set. Okay, whatever. So we will need to request database that has no records, and we also need to check results, and we need to assert results. Yeah, this will be nice. We want, because we don't like abort operation, we like just want to ignore invalid insert, so this guy should return true for sure. And then we can also check that the database has no records added for sure. But to do this we need to compile, and compile will take a lot of time. Holy moly. I use all my cores. I don't need to use all my cores because my machine is lagging. I will need to abort it, unfortunately. It compiled something. It's okay. It's okay to abort it because it cached some results. It's okay. Okay, while it's compiling, let's configure prettier, because currently I can't format this JavaScript. And this is said. How to configure prettier. How to configure prettier. let's just copy some default configurations. Like this. Okay, this file is just prettier JSON or RC. Yeah, JSON or RC file. It's just RC, like just RC. So let's so let's create here prettier RC file and copy default config of this file, and will it help us? No. I don't have prettier globally installed, I believe. Let me check my configuration. Format. I don't know if you hear, but my CPU is actually dying right now because of this compilation. Format. How to format? Go Python yarn prettier. So it wants to install prettier here. Okay, like let's hack our way around and just yarn add prettier. Why not? Let's just install it here and format. Yeah, format is working, but it formats the hell out of this. They have two spaces instead of one tab. 2 spaces. Nevertheless, they have semicolons, as you can see. True. And single quote. Yes, they use single quote. So now format. Something was formatted. Something was really formatted. They have like longer line size. Let me undo the change. For example, let's check the big lines here. Like here, format. Yeah, as you can see, it's collapsed lines. We need to have like longer lines. Do we have like lenses here? Line size, max line length here. Like, yeah, let's take it and put it, I don't know, 160. Will it help? Let's run again. Yeah, it helped a bit. It's 160 is too much, I believe. 100 is enough for anyone. 112. It's okay. So now we have our formatter. It's okay. Where is our test? Now all these changes like intervene with me. This is not good. Because if you check our changes, there's like a lot of formatting. We need to commit them before we can start actually producing our tests, so they not get in our way. Where is our test? This one. So let's just like cut it and stage this and insert it. And now, as you can see, we have only this change and all formatting gone here. It will be much easier to work now because I can jump to changes. Yeah. So now I can have conflict changes omitted. Conflicted changes omitted. Select from what? From data 1. What we want to select? Select value from. Why from is from? Order by key asks sending. What values do we have here? Insert key. We insert 3 records here. 1, 2, 3. Select value, and we only put keys here. Select key, and so there will be key 1, key 2, and key3, like this. This one is not needed. So from database 1, so I would like to check if it's true. Still compiling, halfway there, but we can run this test and see what will happen. Let's run this one, and we get error. T is not defined. T is not, yeah, T is not defined for sure. Deep strict equal. What is deep strict equal? It takes two items and check whether they're equal. But T is not defined. Like whatever. Do we have prepare strict equal? Strict equal. What is deep strict equal? Deep strict equal. It's actually pretty simple. It will when you compare objects in JavaScript, they compare by references, but this guy actually will go to fields and compare them. Yeah. But somehow, what is T? I don't want T. Like, can they write like this? It's not my code. Hold on a second. Can I like remove T? No, T is not defined. Where? 410. T. Where is T? I don't have T here. No T's could be found. The heck? T is not defined. Should support lambda functioning. Yeah, where is T? Confusing. There is no T. Okay, if I remove this one. T. Yeah. Copy and paste. Let's run again. Still error. Country properties of undefined reading strict equal. We need to find different way to compare stuff because this doesn't work. How we can compare? We can compare lengths. Okay, we can compare deep. I don't like deep. What else we can do? See, every time they use deep. But what is T? T is something from here. What is T? Test context. So test context. Why do we need test context? I have no idea why do we need test context. But somehow people use it. Prepare strict equal, strict equal. Who knew? Well. Apparently we need T. I don't know why. I will explore this stuff later. Like this. T is test context, and I don't know what T context means. Yeah, our keys are not strings but numbers. And yeah, that's correct. So now we test that first database has all 3 records, and the second database has only 0 records. Database 2. No. Why? No such table. Yeah, there is no such table for sure. But I need to test it that there is no such table. Throws. Let's use this guy. For sure, this command should throw because we don't have our table. But what error we need to throw? Let's check once again. Come on. Database is no. Oh, this one. No such table. Let's put it. No. Like here. Yeah. So run. Okay, test pass. So this is like kind of cool, but again, it doesn't check this lambda is working. Yeah, because if I remove it, it still passes. Yeah. Why though? Because default behavior is to emit, I believe. Default behavior is to emit. So if I want to really check it, I need to different behavior, abort, for example. And this should return false. And yeah, but will not return false because abort is not working. And we need to do some add support of this abort. What about compilation? Almost done, almost done. This is cool. This is actually cool. I believe this compilation will not produce. Once again. Thank you, Ninja. I don't like Ninja at this in this setup because it produces release output and now it compiles debug output. But I only need debug output. Why do you produce like release output? And spend my time on this nonsense. How much time we have 2 minutes. So what we did today? We did today try to run some JavaScript tests. We tried to understand some. I lose my mark. SQLite CC. SQL. Why I can't find SQLite CC? SQLite CC. Yeah, here. Let's put bookmark here. So we understand a bit about how to unwrap stuff, how to link it, so we can grab that around stuff. Context, yeah, we understand it. Some lambdas, blah blah blah. Do we have formatter for C++? Do we have formatter actually? Yeah, we have some formatter for C++. It's cool. But now we need to fix it here. I have errors. Where I have errors? Yeah. We lost our database. Will Ninja actually produce our database? This is like quite inconvenient. So because I have 30 seconds left, let's think of what we will do next. So next time we'll actually write C++. So today we started write JavaScript and wrote some tests. This test almost test what it needs. Like we'll check that abort is working. To check that abort working, we need to switch to write to C++. And we'll go like this. We'll write some JavaScript, C++, JavaScript, C++, and then we'll compare our solution with solutions the other guys produced. And we'll try to grow. So yeah, thank you once again for your time. If you like my content, please subscribe and push like, and see you next time.